Yo! Oh, freak. I don't have my. I'm so late. I'm sorry. And I don't have my mic hooked up. Let's get it. Let's see if this actually works. Let's see. Is that any better? Yeah, okay. That should be better on the audio. Let's see. Welcome to the production ESP32 stream for today. I'm super late, super late. I'm 3 minutes late starting the stream, and I apologize for that. I was just streaming on Whatnot, which was my first time ever streaming on Whatnot, wildly intoxicating. That has nothing to do with the production ESP32 stream, but it's the excuse for why I am late today. So, today we are going to be talking about logging. My voice is going. I'm talking so long. We're going to do our best here, though. So, I've been thinking about this a lot. I've been getting a lot of questions about this from people in the community, but as well as on projects that I'm working on, which is this idea of logging. Logging is such a giant space, but it is wildly underutilized in the embedded, like ESP32 embedded product world. Outside of, we do IDF.py monitor, we can see things, but what I really ultimately want to do is integrate first class logging into my service deploy the fleet. But outside of that, just capturing logs, there's a lot of different scenarios that we want to do this in. Testing, like long running burn-in tests. It'd be nice to let this run 24 hours a day and have something collecting logs for you so that if you do run into an issue, it's not one that you have to be right there for. You can go back through and say, oh, at like 2 a.m. it locked up and crashed. I can go back and look at the log and at least get some information of why that's there. So like that's one version of it. The other version of that is production logging. And so there's a trade-off here of whether it's battery powered and you have the energy to afford doing logging kills on runtime. If you're trying to do battery powered, you want to minimize logging to like nothing because that is a huge time waster. Production tip if you didn't know. But also, there's a fine balance there, right? Of like collecting logs so that you can identify issues. If a customer calls in with an issue, you can then go back and correlate that and say, oh, I see, maybe what happened here. And so uh, to start that, I want to start at the very beginning today and just mess around with logging in the IDF and just some of the settings and go through that, and also how we can, what I've experienced in the past and what I eventually want to look at solving is even the IDF is very inconsistent in how it does logging. There are still places in the IDF that just do straight printfs, so they don't go through the logging mechanism. And so even if you turn off logging for some things, you'll still see some printf statements. And so I believe there's a way to hook into that before anything starts. Not printfs, you're not getting around that, but to be able to basically create an abstracted logger, because then what I want to do is I want to be able to just send it to the UART like it normally does, or store it in a flash partition like a running log, or push it up to the cloud, send it over MQTT, send it over HTTP, maybe even send it over, like the transport shouldn't matter, but and that's the whole point. Like if you have an abstracted logger, you can just put the the source of your logs, you can make the sync anything that you want. And so that's the idea. And let me roll up on chat here, make sure I'm seeing everything. Okay, so this is, I finally went through and reset our testing project. And let me make this bigger so people can see it and make this smaller. So this is just super, super simple. Welcome to the Deploy the Fleet SDK playground. We're not doing anything with Deploy the Fleet on this. This is just a containerized Docker on IDF. I'll show you here, idf.py version. We're on IDF 5.5, so we're on the latest stable. And this just gives us a nice little playground. I have this connect to Wi-Fi, which connects me up to my Wi-Fi, and then I can do, I can play around and test things. So let's just go ahead and hit idf.py monitor on this guy. And we should just see connecting. Oh, I didn't reprogram it, and it's got the, let's do idf.py flash monitor. Okay. And so that'll flash. And again, it's just going to say connecting to Wi-Fi, and then it's going to say current version every 5 seconds and go through. And so let's get that running, and then let's play with logging settings, because these, they're not particularly complicated, but the very first time you come through and you do logging, there's some things that can trip you up, and so we'll go ahead and look through them. First and foremost, let's make this bigger to have like a baseline here. You can see I'm only logging a couple of things, like a few strings here and there, but when we look at our output, you can see like I'm getting all of these things, like all of these logs. I didn't turn any of this on, and that's because by default, you have some default log settings. So let's go ahead through and look at those. UJ Tech, thanks so much for joining. Appreciated having you on the last stream. It was great. I appreciate you coming back. We're talking about logging today in IDF. Super boring, but essential in production commercial applications. Okay, so what you'll see right away is this thing that is referred to as the tag. That's right after the timestamp. So you get, let's go through the whole thing here. You get the log level indication, I, E for error, W for warning, D for debug, V for verbose. You get the time in milliseconds since boot. This is the tag. In this case, it's main. And then you get your message. And so you'll see, in addition to main, which these are my logs, we've got this ESP netif handlers, we've got Wi-Fi, we've got Fi init, we've got Wi-Fi init. And so you'll notice, yeah, that's a distinction here. Wi-Fi is one tag, Wi-Fi init is another tag. And then we have SPI flash, heap init, like you've got all these things that come all the way up, and boot. So there's two places that logging is going to happen in your project. There's bootloader logging, and then there is application logging. And so let's start with, well, let's start with the bootloader. Yeah, why not? Let's start with the bootloader. Okay, so we've got all of this boot. It's showing second stage bootloader, compile time, all this fun information. If you have flash encryption enabled, the bootloader is going to show you a bunch of information of what it's doing there. I believe these are coming out of the bootloader as well. At some point right here, Pro CPU start user code, and then you have app init. This, I'm not sure. I think right here, 415, this multi-core app, that's going to be the first log outside of the bootloader, but that's why we're streaming this stuff, so we can all learn together. Let's play with it and figure it out. Menu config, and we're going to do bootloader config, again, which is separate from the main application logging. So application rollback, bootloader optimization level, log. So let's go into log. They did introduce in, I think, 5.4, maybe it was 5.5, I can't remember. You can select V1 or V2. I guess in the bootloader you only get the V1 option. But bootloader log verbosity is set to info by default. Let's see what other settings. Text log mode, that's the only option we have. Format. Oh, color. Interesting. Color is not checked, but it is definitely printing in color. All right, so this is a side tip. If you are doing some encryption stuff and you're messing with partitions, your bootloader can grow to be too big when you do flash encryption. One of the simplest ways to reduce the size of that, if you're comfortable with it, is to change the log verbosity. So you can turn on secure boot and flash encryption. Every time, 100% of the time, you're going to get an error saying that the bootloader is too big for the default partition table that it's set aside for it, and you will need to make some changes to your partition offset and things like that. Or you can change this, I believe, error. If you change it to error only, it reduces the size of the bootloader enough that it'll fit in the standard size partition that is set aside for the bootloader. So we're going to change this to error. Actually, let's just change it to none because I don't have any error. So we're going to change it to none, and we're going to exit out. And we're going to, let's speed this process up and do 3, 4, 5, 6, flash, and you have to have high monitor. So it'll flash faster before it goes into the monitor. All right. Okay, for everybody joining, we're talking about logging in ESP production application of the ESP32. If you have any questions or things you want me to try, just stick it in the comments. I believe if you're watching on LinkedIn, I think I get comments through LinkedIn. I don't get comments if you're watching on X. I do through YouTube for sure. Okay, let's see what we got up here. So we're going to come all the way back up to the top. And yes, look at this. So the very first log entry we got is this multi-core app at 3. And look at the time. It's at 3:27. Let's just come way back up. Hopefully it's still in the buffer here. Multi-core, where was it? Multi-core app right here, 4:15. So almost 100 milliseconds off of boot time just by getting rid of these logs up here. And again, once you get to a certain point with your firmware and your comfort level with things, like this isn't really telling you anything that you don't know, and so it is completely unnecessary and is just slowing the boot speed of your device. So cool. So let's come down here. I'm still not sure where this stuff comes from. Especially this. Like, I'm not sure how we would get rid of that. I mean, it is in the bootloader. So this is where what I was saying at the top of the show was IDF is inconsistent in how it does its logging. And so these are clearly not logged with the log system because they don't have the log indicator, timestamp, and all this other stuff. This stuff I think is important. But these things, I'm not sure where they're coming from, and we could probably come in and we might even be able to like click and VS Code will take us there. Let's take a look here. Attribute no return called start CPU. We arrive here after the ROM bootloader finished loading this second stage bootloader from Flash. The hardware is mostly uninitialized. Flash cache is down and the app CPU is in reset. We do have a stack, so we can do the initialization in C. That was an extremely helpful comment. And so, yeah, then this is what's going to launch your main application. And that's why the next thing we get here is pro CPU start user code, and then we go into app init, and then now we're logging app stuff. So now let's say we don't want to get all of this stuff. So now let's look at application logging, not just bootloader logging. Again, this is the beginner level of logging in IDF, but important to understand. So now we did bootloader config before, but now we're going to do component config. And we're same thing. There's a log down here, log. And we should be able to choose, yeah, log 1, v1, v2. You can read up. I'm not going to cover that in this stream. I read the release when they first launched it. I didn't fully understand what the differences were, but that's where we're at. Log level. And again, the default is going to be info. And then there's a couple of things here. These level settings are going to be the enable master log level. Enables an additional global master log level check that occurs before a log tag cache lookup. This is useful if you want to compile in a lot of logs that are selectable at runtime, but avoid the performance hit during periods where you don't want log output. Okay, so this is great. Examples include remote log forwarding or disabling logs during a time critical or CPU intensive section and re-enabling them later. I'm interested in this now. I've never played with this. Enables an additional global master log level check that occurs before a log tag cache lookup. Okay, I'm gonna have to play with that more later. That sounds very interesting and feels necessary for what I'm ultimately trying to accomplish. Enable dynamic log level changes at runtime. This is important because this allows you to do this ESP log level set, which is what we're going to start playing with here in a minute. And so you can change at runtime what you want the log level to be at different times of program output. And I mean, thinking about this right now, I think the reason you'd want to do that is if you have a device running in the field, you're probably going to run with logs off because nobody's watching them unless you're uploading them, right? And if you are, you'd probably want to do that statically enabled, not dynamic. But let's say you have a troublesome device in the field, and now you want to send an MQTT message or some setting down to the device that says, "Hey, this thing's being troublesome. I need you to go into debug log level instead of warning or error, and to start showing me more logs." So that's just one reason why you might want to have dynamic log level changes enabled. And maximum log verbosity. Okay, so there's two things here. Default log verbosity is what, again, you can see in the main, I've made no changes to log level, and it's just what it is. It's set as info because of this setting. And then you have the maximum, which currently is same as default, which means I can't see anything above that. And so before we change any settings, let's establish a baseline in our program so that these changes are easier to see. All right, so, and we actually don't even need to connect to Wi-Fi. That's just wasting our time for the purpose of the stream. So we're not going to do that. But before we go into our while loop, let's just do, well, actually, let's just do it in our log loop and then change this to a higher, like a minute or something. Okay, so we're going to do a log I, but we're going to also do an ESP log V. Main, and actually let's do, yeah, main. This is a verbose log. I went too many there. Now let's do a log D. Debug log. Then we're going to do info. We're going to do warning. And sure, Copilot, thanks. I appreciate it. This is an error log. Okay. And now let's see what we get when we run this. And you'll see, what we should see is we get everything info and above. There you go. Okay, so you can see we've got the current firmware version is 2. That's our info log, and you can see it's doing coloring here. And then we get a warning, and then we get an error. Notice you do not see the debug or the verbose, and that's because that setting says the maximum log is the same as the default. That's why that's happening. And so what we can do is we can come into IDF by menu config, come down to log, and change this maximum log verbosity to something that's lower. So let's set it to verbose. The default is info. And yeah, there we go. The other thing we can do here is you can see color is turned on, and that's what does the makes them, red or green or yellow. And so I'm going to turn that off, and we're going to see what our output looks like now. Okay, so exact same code is running. I just changed menu config settings around logging, and we'll see how that affected our output. Okay. Now, you notice didn't change it at all. So we still are not seeing the verbose and the debug, and that's because again the default is info, and it's still in color though. Why is I wonder if IDF Pi is doing the coloring for us. I bet that's what's happening. So I don't know that I'll show it on the stream here, but when color's enabled, it's using the shell color code stuff. So if you're dumping that into and you know what, I might be able to show this. Let's try this. Um, it's cu-l dev/tty USB 0. What? No matching ports. What are you talking about? Stand by. We're getting there. I think it would be interesting to show this. So. Oh, the speed. There you go. I had that wrong. Okay. Let's clear this. I'm gonna pop this up in here, and I'm gonna paste that in, and I'm gonna stop monitoring, and I'm gonna hit reset here. Okay. So here you can see there's no coloring whatsoever. Because yeah, so IDF.py is definitely doing that for us. That's the only way that can work. But for fun, let's exit out and let's change it back to color. Log format, turn color back on. And the reason I want to show this is because what I have gotten into for some projects is into log collection, like I was talking about earlier, and the color really screws that up when you're just trying to grab raw logs. And we might not see this, but you'll see the color change. But when you're grabbing the raw logs, you're going to have a whole bunch of this extra junk prepended and appended to every log line that you're going to have to weed out later. And it's no fun. Okay, in this case, what I think we should just see is that the color, yeah. So now you can see I'm getting color now because the terminal itself is responding to again, all those special characters that it's putting at the start. It looks awful. Like, that is really terrible. I don't know how it's coming through on the stream, but so anyway, that's color off and on. IDF.py colors it for you. That I just learned that on the stream, so that's handy dandy. So you can turn it off and still get your colored logs with IDF.py monitor. So that's kind of cool. But sorry, we got sidetracked. We still were not seeing our verbose and debug logs. And the reason for that is because the default is info. And so what we can do just right up here at the top of our main, if we want, is we can do ESP set, I think it's set log level, ESP log verbose. Did I do that right? No. But I'm fairly certain that that's what it is. So we might have to include something else. Set log level. Oh, I didn't put the tag. So that's going to be, oh, maybe it's not. Well, I'm skating right around it, which is killing me. Logging, come on. Logging. ESP log early. I do want to play with those. ESP, oh, log set level. Oh, log level set. Here we go. Log level set. ESP log. ESP log level set. And we have to give it a tag, which will do main. And we're going to set it to verbose. Yes, thank you, Copilot. You've done a great job. Okay, there we go. Now, we should see the terminal will show everything. UJ great question. The terminal will show everything that you see through IDF.py all the way back to the beginning. I was just using CU, but okay, and you can see, interestingly enough, verbose and debug don't get any coloring. That's just I guess just an IDF decision. But now we are getting the verbose and debug logs. So now we're getting all VDI, EW, and E. Great. Now, just a couple of things to cover really quick on this. This, you can set the tags here, but you can also do something like this. I've never done this. Star. It'll take wildcards. So you can say star and say, I want logs for everything set to verbose. Let's see what we get. This is going to be crazy. And that turns on logging for everything. And so you'll see on the output of this, it's going to be, yeah, see, you're getting mmap, calculated MD5, stored MD5 partition. Oh, actually not much additional there. Okay. But when you do something like Wi-Fi, if I turn Wi-Fi connect on, let's do it real quick. Connect to Wi-Fi. You're going to see a lot more logging. So we did get some extra partition and MD5 stuff there, but now let's turn it up to 11 here. Yeah, there we go. Okay, you can see like it's given us a ton of things of extra verbose and debug logs. And this is really, again, this has come in handy a few times when I've had to actually find a bug down in the IDF. You can turn on their logging. But anyway, so that's just how you play with that. You can also do the opposite to say dynamically at runtime, I don't want logging for anything. And so if we just set that to none, that'll work as well. And you'll see we're going to get very little output. That initial block that I still don't know how to turn off. And then we should get nothing after that. Yeah. Okay, so calling at main. And that's because these were all run before you got to this line of code where you turned it off. You could set the default to, you know what, this is the point of the streams. We're playing around. You could set the default to none and then correct it in your code. So let's just do that really quick. Okay, log level. You can see the default is info, and let's just set it to no output as the default. So sorry, let's come back in. We can go from no output all the way up to verbose on any of the tags. And so let's check our output on that. Almost there. Okay. And again, this is that blob at the top. But after that, oh, you know what? I actually think that this load stuff and entry, that may be IDF.py. Let's, what did I do with my terminal? Let's bring it back. Let's cancel out of this. Let's bring this guy back. And then let's hit the reset button. Okay. Yes, this is top level. So yeah, and UJ Tech, this is answering your question. You do see all of that stuff, but you'll notice here. Let me pull this up. We're not seeing these lines because these lines are put in there by idf.py because it's doing some extra stuff to be helpful, but that's not actually, it's translating this address. So it's saying I'm loading 4008 and it's just telling you what's located at that, which is this, and then it's saying what's located at this address. And whereas the actual raw output is just telling you it's loading those addresses. So that's your boot up code launching your application. So cool. Let's get out of here. Okay, so that is how we turn logs completely off. And so now let's go back to the default mode because I just want to show something that I found to be pretty helpful when I'm deep in a project and trying to look through logs because it gets messy. Okay, I forgot to turn the default back to info. Dang it. Let's do that. Log level. Go back to info. Okay, so I mean, I guess the point I'm actually trying to make is you can turn it off by default and you'll get nothing. If you're in info and want to turn off, and actually now that I'm thinking about it, I would default to off once your product is in a mature state where you're iterating on releases, and then only enable logging that you care about because I'm actually going to show you the opposite right now, which is by default you're going to get all this logging, and you might say I don't really care about that. So let's use this as an example. I'm going to leave Wi-Fi on. And it's like, well, I got all this logs I'm looking through, but really all I care about focusing on right now is Wi-Fi and NIT. And so what you can do is you can do these in order. So you could say set the log level for everything to none. And then I want to see Wi-Fi and NIT, everything that is info or above. Like that. And what that'll do is that'll turn everything off. Again, you're going to see that top stuff that gets logged before we get into our main. But after that, you won't see any of the other Wi-Fi stuff. You won't see any of our main logging. You're just going to see the Wi-Fi init stuff. So it's going to go through, and here you go. This heap init stuff, this is before we got into our code. You don't even see the app. Oh, here you go. Calling app main. This is all before we get into main. And then after that, you can see all we're getting now are Wi-Fi and NIT. And so that's just a way, when you get these bigger projects, you're going to have tens of thousands of lines of logging possibly from all different kinds of modules and tags. And so you can go around and play with, hey, this is, I just want to see error logs of this tag. And so anyway, that's a way to do that. And let's see, let's turn that off and that off. Again, the tags are whatever you want them to be. So we can change this to main V, or sorry, main D, main I. Typically it's the module that you're in. So we're in main here. So these all would make sense to be main, and you might build a driver out for a sensor and you would call it the DH11. W E, an optocoupler or whatever ADC. You can. The point is you can make these whatever you want. And the debug and verbose won't even output because we have that turned off. But just to show you that you can get different tags, and they're just free strings, whatever you want. Wi-Fi association, I can turn that back off to get straight to the, so here you go. Now, so let's actually just try this and say set log level I've only ever used star. I've never tried something like this. So let's try this. See if this works. Main star. Set it to verbose. So that if you have like sub tags for a component or something, how would that work? I have not done that before. Oh, and I forgot to turn Wi-Fi off. That's slowing us down. Oh yeah, so sweet. Look at that. Although it didn't. Oh, okay, so maybe that didn't work because it's still set to info. So that's why these are coming out. So that did not work. So this main star does not work. You can do star, which is everything, but main star isn't going to say like everything that starts with main um, will be set to that level. So that's good to know. So star applies to everything, but I guess wildcards like that do not work. What do you suggest to keep the logging turned on or off for field products, as this one uses UART? Yeah, so again, UJ Tech is a great question. It does depend on the product and the deployment environment, and can you have logging enabled? Is it wall powered? Is it battery powered? Would the logging be useful to anybody? You know, it might be a technical thing where there's a a service port on it that you would plug in. My generator actually has one of these. I have a Generac generator. There's a service port on it that just breaks out a UART, and you can actually see logs coming across it. I think they did patch that to encrypt it, but um, so like in something like that, maybe you have logs running because the time doesn't bother you, and so and then you might have a tech that has a special equipment, which is just a UART reader to see those logs. But then what I've done for like I was just streaming about this earlier. My puck holder product got an ESP32 in it. This is battery powered, and it has logging enabled because there is a little. I don't know if you'll be able to see it. Anyway, there's a USB port on the side with a serial input that allows you to, in the worst case scenario, actually do a console to it and do some commands, reset Wi-Fi and stuff like that. But I've also done other battery powered ones where nobody's looking at the logs, there's not even enough energy to send logs, and so I just turn it off in menu config. So I wouldn't mess around with any of this set log level. I would just statically disable it in menu config so that there are no logs whatsoever. So it's really just finding the balance of what works for your specific product. Okay, and then this finally built, and yes, as you can see, I turned logging off for everything, and then I tried to wildcard turn it back on for all of my mains, but that did not work. So this, I thought that was supposed to work, but I guess not. I guess star is just what you get. Um, Note, tag of the log entries to enable must be a non-null zero terminated string. Value, okay, here it is. Value star resets log levels for all tags, but it does not do. I thought it did do wildcard. It obviously does not. Okay, so star is just a special case, meaning all logs, and so you can't do that. All right. I think that's all I want to cover for today. Just a quick run through of basic logging using the raw ESP log functions. Because again, you can do something like this, printf. I'm not using the logger. I don't know if I have to include anything for that. Nope, that'll work just fine. But you lose, this set log level and stuff. You lose the ability to dynamically set those things. What would be interesting is to look at the stack impact of that, because logging is going to absolutely kill you on stacks. Like If you have a thread running that's really high and tight and you add logging to it, and you don't have very much stack allocated to it, you will get stack overflows immediately. Like the first time it tries to log something, because logging is just a killer on stack space in those tasks. So something to be aware of. And you'll see this. This just will, even the IDF logger will not color this. Interesting. Where? Huh? That didn't output. So now I'm interested to know why. I didn't think printf went through the logging. Huh. Let's that's interesting. That's new. And let's turn this Wi-Fi off so we don't have to wait so long. Come on, you can do it. If it prints out, it didn't at all. Interesting. I'm not sure. I've done printfs before, and they work just fine. So I'm not sure why that is not showing up. I have a project actually that I do that in. .com. Mayor crew. Let's just go there. Wonder if there's something else that I've. Not CBP. Printf. Is it? No, I've got scenario. I'm not sure why that's. Wow. Well, let's. I know for certain that has worked in the past, so maybe something new. Let's do a search for printf. Enable ESP-ROM printf. No. Enable. That's not what I want either, I don't think. I wonder if it's just not. Okay, we're going to try something here. Let's move this up to like here. I wonder if the thread sleeping has something to do with it. Interesting. I am not using the logger. Look at that. And again, I didn't put a just slap a new line on the end. I'm also curious if IDF pi will, if I just make something up here, test, like if I simulate an info log, if it'll color it still, just because it sees the eye. But why didn't? But that does not print if we put it down here. Let's check that out. That does not make sense to me. It did. Check it out. I'm not using the logger. But I bet you if I drop the I, it's not going to do that anymore. Okay, so that it worked that time. Why? I can't explain that. Did I just not save it before? I'd have to go back and watch the stream, see if I just didn't save it. Yeah, because it's definitely printing. Now just to go back into the total way it was before, like that. I wonder if it's not flushing because there's no new line. If it prints out here, then it's probably seriously just user error and I did not save the file. No. Okay. So it does not print out. And now let's add a new line in there and run it again and see if we get it. Okay, so yeah, it's probably the underlying system is not flushing because there's no new line. So that is a nice tip. I'm going to reset this several times. Yep, it's working. And now I'm going to take the new line off just to make sure we're not hitting like a race condition or something. So what will be interesting is these are all going to force it's okay. Yeah, so it's not anymore. And now I'm going to just redo this a bunch of times. Yep. It is just, it will not print. And then I wonder if we call multiple. I'm the second log. Like if we call it multiple times, still without a new line, that's definitely saved. This might be an interesting. What ESP log using under the hood? It should be the same as printf, right? That's great. EJ Tech, your questions are spot on. Look at that. It is just not, unless you do a new line, it's just not flushing that buffer. But I bet if we throw an ESP log after this, log I, main, flush it, check it. I bet all of it dumps. Like it takes the back buffer and everything. But I wonder if there's at some point you're gonna, the buffer's not infinite, right? So you're gonna overflow that at some point. Yeah, here you go. I'm not using the logger, I'm the second log, and then flush it. Okay, that is a great learning that I was not aware of. And then if we put new lines in here, usually I haven't forgotten about your question. We are totally going to answer that here in just a second. And run that. We should get them perfect. I guess I'd need to take off the flush it to prove that, but I'm positive that that's what it is. Okay. Okay, so add new lines to your printfs or else they are not coming out on the UART. They're just going to be stuck. And again, I wonder if there is a buffer that we would, oh, look at that. Oh, because I put because there's new lines on it. Okay, yes, but it does work without the ESP log. I'm the lots of numbers log. I wonder if we can overflow that or something. How big the buffer is. Okay. Okay. So at some point, without doing a slash, without doing a new line, at some point you're going to force the buffer out. And it's probably and the second log. Who knows how many it is. But yeah, okay. So if you print F enough, you're going to force that buffer to flush itself. Who knows what that limit is. We could sit here and play with it. I'm sure we could dig way down into the source code and find it. But the last thing we'll do, because we're getting short on time, is we're going to answer, yeah, so that many, it still didn't print out. Okay, EJ Tech, let's come into the logs. And we can just go to definition. And it's calling ESP log level local, which we're going to, no references found. Oh, come on. Didn't turn notifications off. Sorry about that. Let me just do that really quick in case this starts to pop off. Pause notifications. Great. Okay, so ESP. Oh, I've been down into this before. Why won't it take me to the definition? No references found. PDF. We'll do it the hard way. It was log level local. And I'll figure out why IntelliSense isn't taking us there. Logs. Log.h. It's not going to show us. And I also feel like I've done this. Maybe with IDF5 it's different. I forget the syntax. It's the find command, but I don't remember. grep-rnw. Okay, so let's text that out here. Come into ESP, IDF. Let's do a grep-rnw. From here, for ESP, this is going to give us a ton of stuff. Log level local. And see if we can't figure out define. Here we go. This looks promising. ESP log level local is calling ESP log level, which is not taking us to where we want to go, but maybe just be in the same file. If ESP log version 2, else, so it's calling ESP log. And ESP log. All right, let's do a search for that. Let's do void ESP log. Is defined where? Log include. So let's do yeah, components, log, source. Just look at log.c. And see what we can find. Yeah, so it's going to eventually come down into here. So, yeah, because you can override. This I know about, and this is something that's interesting to me. You can override the system version of logging by defining this weakly linked ESP log vprint func and have it do whatever you want. And so ESP log format message. Here you go. ESP log VA. And ESP log VA is calling ESP log format. ESP log format is calling ESP log printf. And that is calling vprintf. Inline void and it's calling ESP log vprintf. We're going down. We are down the rabbit hole. This is ended up calling ESP log and equals sets to vprintf, and this is where you can override it. So where's vprintf? So UJTech, yes, it's calling vfprintf all the way down at the bottom. So yes, it's basically calling printf all the way down at the bottom. And so whatever buffering is happening, oh, I'm glad we went all the way down there. That was great. Whatever buffering is happening somewhere else in the IDF. Getting that out to, we'd have to find the vprintf and see what it's doing at the actual chip level there to see. But we are out of time for this stream. Hopefully you learned something about logging, just a little bit of the basics of how we do logging in IDF compared to other platforms. And again, what I highly recommend for anybody doing a commercial product is to create some sort of wrapper on this. Some abstraction around these calls specifically, because if you ever do need to port, you don't want to carry all the baggage with you. You just want to be able to replace some very tight implementation details. In this case, it's using these log functions, and there's some other things that you can do with IDF to override that. But that is going to do it for the stream today. Thank you so much for watching and joining. I appreciate it. If you have anything that you want to see in the stream, actually, let me just do that really quick before I sign off. I've got this vote for the next stream. This is productionesp32.com/voting. I am going to do CI. Everybody wants to see CI, but you can vote for what you want to see on the stream. If not, you can send me an email right here with an idea. Any and all ideas will be added to the list. I'm happy to just, again, it's fun for me to learn this stuff and dive deep on it and answer questions. So that's going to do it. I hope everybody has